Now that we have the displacements at the nodes, let's move on to post-processing. And the first thing I look at in structural problems is the deformed shape and also the displacements, because we have an intuitive feel for what the deformed shape should look like. I see students jumping straight to stresses, which are less intuitive, so I recommend starting with the displacements and the deformed shape. Let's do that. And before that, quickly going back to the framework of the black box, we are, if I go and enable inking, so we've input the boundary value problem into ANSYS, we provided a mesh, and ANSYS has obtained a numerical solution, and that is approximate and the numerical solution is to that boundary value problem, and then it got displacements at the nodes, and so we are moving on to post-processing. And if I go to my my ANSYS model, okay, and I'll go here. Let me manipulate the view, zoom out using the middle mouse wheel, so that the z-axis is kind of like that, and let me translate and zoom in. Maybe something like that. Okay, and so I'll highlight solution in the tree, and I'll say deformation total. Right click and say evaluate all results, which is telling ANSYS, hey, post-process this result, which comes from the interpolation of the nodal displacements. And so you can see that goes from 0 displacement all the way to the maximum displacement, which is at the right end. And we can, if you look carefully, we can see that there is a twist, and these displacement, this is exaggerated by a factor of 170. So if I go, and I can animate this, which is useful to check how the object is deforming. So if I bring that in, and if I animate it, I can see the twist. And I can even make this a little bit slower, maybe 10 seconds. And I also sometimes turn off the contours because I find that a little bit distracting. So if I do that, I can see the twist, okay, which is consistent, and there's 0 twist over here. So that's a check on the boundary, on the displacement boundary condition at that end. And there seems to be a radial expansion, which is actually, I think, an artifact of exaggerating the displacements, because later I'll indicate how you can go and look at the radial displacements, and you'll see that they're pretty small, almost negligible. Okay, and let me turn back to smooth contours. And so then looking a little bit closely at the trends, the displacement, so this is the displacement magnitude. It increases as we move away from the fixed end, which is what we expect, because the cross-section over here is twisting more than the cross-section over here. And then if I'm looking along a cross-section like that, I see that there is in the circumferential direction, the displacement is the same, which is what I would expect if there's just each cross-section is just rotating. So in that case, I would see that, a node over here, if it's just moving over here, and a node over here is just moving over here, they should have the same displacement. If they have the same rotation, and then I would expect that the node over here would move more because it's farther away from the center. So the trend within the cross-section is also consistent, is consistent with rigid body rotation. And the rigid body rotation also tells us that we expect that the displacement out of the plane of the cross section should be small, which is the displacement in the W direction. So we can take a look at that. So what I can do is I can highlight solution in the tree, and now I can say deformation directional, and let me rename that. Right click and say W contours, W for displacement in the Z direction, and so the direction is Z, and then evaluate all results. And I can move this. Now if I look at the scale, you see this is of the order of 10 to the power of minus 14, which is 0 to round off. So essentially there is no displacement out of the plane of each cross section, which is consistent with the assumption made in the analytical or the hand calculation approach. And if I go back to the total deformation, and let's say I want to save this view, I can do this in two ways. I can get rid of that and say you want to put that in a report. You can say over here, image to file, or you can go here and you can say snip, and you'll get the snipping tool in Windows, and so you can just take a snapshot using the snipping tool. So if I say snipping tool, I would say new, and then just draw. I won't save it here in the interest of time. And oh, the other thing I wanted to show you is that you can take cross sections through the model. So if I'm looking along the x-axis, and then I'll say new section plane, and then I can cut it. You can see the cursor, has that has an additional symbol showing that you can take a section plane. So let me say I will cut it like that, and now I can go and say highlight section plane, and I'll say edit section plane, and then I can move it. So that's a handy way to look in the interior, and you see that everything is consistent with rigid body rotation. And then I can deselect the section plane, and then it'll disappear, and I can re-enable it if I want. And so I will go and I will save the project.